A complex fraction has a fraction in both the numerator and denominator. They look like this. You guys see how I have a fraction in the numerator and a fraction in the denominator. Okay, this is called a complex fraction. The way we simplify these, we're going to make sure to create a single fraction in the numerator and the denominator. That is step one. So what I mean by that, notice how this one is not a single fraction. That's two different fractions, okay? You can think of this as 1 over 1, right? That's not a single fraction. This is another example. This is 1, 2 fractions in the denominator and 2 on top, okay? So step number 1 is to make sure that you create it into a single fraction. Step number 2 is you're just going to set it up as a regular division problem, and then you're going to simplify, and you're always going to factor if you can. Okay, so let's try this first one. The first step is to create a single fraction in the numerator and denominator. That is already done, so I don't have to do this step for this one. Now we're going to set it up as a division problem. Remember, we're going to keep the first fraction, change to multiplication. We use a point for multiplication, and then we're going to flip the second fraction, okay? Keep, change, flip. So I'm going to write this as 2m squared minus 2m minus 40 divided by 3m plus 12 times, I'm going to flip the second fraction. So this will be 9m squared plus 36m. See, that was originally on the bottom. Now it's in the numerator. And this numerator will now be on the denominator. So m cubed minus 5m squared. Okay, so that's step number 2. Set it up as a division problem. Now we're going to simplify this. And of course, you're going to factor first if you can. You can't just start canceling things out. So I'm going to go ahead and factor this one. What can all of these be divided by? A 2. So all of these can be divided by 2. So this can actually be written as, 2 times m squared minus m minus 20. I divided all of those by a 2. Okay, I need two numbers that will, so I'm going to rewrite this problem. My 2, I put it on the outside. I need two numbers that multiply to negative 20, but add to negative 1. Yes, exactly. M minus 5 and m plus 4. Okay, so that's the top left one factored out. That's this one right here. We factored that one. Now let's factor this. What can both of those be divided by? A 3. So that means 3 is on the outside and m plus 4 is on the inside, right? Because 3 times m is 3m, 3 times 4 is 12. So that is factored. Now let's move on to the second fraction, the one that we flipped. Okay, what can both of these be divided by? What, Patricia? Good, so 9m is on the outside. I can just extend this. Okay, the 9's cancel, the m's cancel. I'm left with m plus 36 divided by 9 is 4. Okay, next one. These can both be divided by what? Good, m squared. So m squared is on the outside, and I'm left with m minus 5. Okay, so it's all factored. Now I can go through and simplify. So m plus 4 cancels with m plus 4. M minus 5 cancels with m minus 5. One of these m's cancels out with one of those m's. So let's see what we're left with. I have 2 times 9 is 18, and I have an m plus 4 left over 3 times a single m. That's 3n. We're almost done. What else can I do? Yep, divide these both by 3. So 18 divided by 3 is 6, and 3 divided by 3 is just 1. So this is my final answer. Okay, great questions. Here's the next example. So your first step is to create a single fraction in the numerator and the denominator. So guys, this numerator is a single fraction. That's good. However, the denominator has 2. That is not good. So we need to work on the denominator. So I'm just going to write out denominator. So you know what I'm doing. I'm going to copy the denominator. It's 1 minus W over W plus 2. All I did was copy the denominator. Okay. So we need to create one single fraction. So I need to add, or I need to subtract these. I need to put them as 1. So you can think of this 1. You can think of this 1 as 1 over 1. What do I need to do to make these the same? Yep, this basically needs to be a W plus 2. 1 times anything is itself. So we're multiplying by W plus 2, multiplying this by W plus 2. So keep the denominator the same. The numerator is W plus 2 minus W, which is just 2 over W plus 2. So this is my denominator. Okay, so I'm going to rewrite my problem. This is perfectly fine. I'm just going to rewrite it. W over W plus 2. I changed my denominator to be a single fraction. It is now 2 over W plus 2. Okay, so guys, we did step 1. We created a single fraction in the numerator and denominator. Now we're going to set it up as a division problem. So you keep the first one, change it to multiplication, and you flip the second one. Oops. The 2 is now in the denominator, and the W plus 2 is in the numerator. And now simplify. Your answer is W over 2. Okay, here's another one with 2. I'm just going to work on the numerator. I'm just going to say top for short. Mathematically, we call it the numerator. So I have a squared over a plus 3 plus a squared over 5a plus 15. Whenever you want to combine fractions, the denominator needs to be the same. So how can I rewrite this? Yep, I can pull out a 5. It's now 5 times a plus 3. I can rewrite this as 5 times a plus 3. Now that I factored it, I can easily look at it and tell what I'm missing. What is this denominator missing that this one has? A 5. So I'm going to multiply it by 5 and multiply the numerator by 5. Okay. Now that my denominators are identical, they both have a 5 times a plus 3, we can now add the numerators. This is 5a squared plus a squared, which is what? 6a squared. I'll just write this as 6a squared. Okay, so that's the top. We turned this and this into a single fraction. Okay, let's do the same thing to the denominator. We need to turn it into a single fraction. So can you guys look at this? What does this one need? A 5. Good. Everyone put 5 and 5 on the numerator and the denominator. What does this one need? A plus 3. Perfect. All right. Now they look identical. So let's look. This denominator, when I combine it, 5 times a plus 3 remains the same, but I have 5a plus a plus 3, which is just 6a plus 3 over 5 times a plus 3. Okay, so guys, this is my denominator. I turned it into a single fraction. All right, so guys, this is the numerator rewritten, and I have the denominator. So now we're going to set this up as a division problem. The numerator will just stay the same. So I'll have 6a squared over 5 times a plus 3 times, what do I do to this denominator? Flip it. So I'll have 5 times a plus 3 in the numerator and 6a plus 3 in the denominator. All righty, let's simplify. Well, those are identical. Your answer, 6a squared over 6a plus 3. And I better not see anyone do this. That is absolutely wrong. You cannot cross those out. If you want to cancel things out, they need to be in factored form. So the way you would simplify this, guys, because this is completely wrong. Uh-oh, I erased my 3. If you want to simplify this, you can divide both of these by a 2 so that the denominator will be 2 times 3a. Oh, sorry. Divide them both by a 3. Okay, divide them both by a 3. So 3 is on the outside. 6 divided by 3 is 2, so this will be 2a plus 1. And then I have 6a squared on the top. This can simplify. You can simplify the 6 and the 3. So this will become 2a squared. Whoops, that's too dark. 2a squared over 2a plus 1. That's your final answer. The reason why you can't just cancel stuff out, that's like trying to do this. You can't do that. The reason why, think about this. Let's do 1 plus 3 over 1 plus 2. What is the answer? 1 plus 3 is 4. 1 plus 2 is 3. Okay, so I know that this side equals 4/3. If you just cancel that out, is 3/2 equal to 4/3? You can't just cancel stuff out like that. If you're adding and subtracting, you can't just cancel it out. Now it's different if you're multiplying. Let's see. Let's say I do 2 times 3 over 2 times 5. This is what, 6 over 10? And this simplifies to what? Divide by 2, divide by 2. It simplifies to 3/5. You can cancel those out and you still get 3/5. So when you're multiplying, you can cancel things out, but not when you're adding and subtracting. Here, you're adding and subtracting. You can't just cancel those. Can't do that. Okay?